In this video, we are going to study use substitution for integral of power function. First, it is important to know when to use usub for power function. This method is used when derivative of inner function is given along with. It's not necessary that the derivative is given in exactly same form, but the variable part of derivative must be there. For example, here the function is 5x raised to 4 plus 2 and its derivative is 20x cube. The variable part of 20x cube is given here. So don't worry, we can manipulate this function a little bit to make it exactly 20x cube. So let us see how we work on these kind of functions. First we assume the inner function as u, then take derivative of both sides. We get 20x cube. The derivative of constant 2 is 0. So here the derivative is 20x cube dx. In the given expression, we are given only x cube. For that, we divide both sides by 20 and we get x cube dx equals du over 20. For step 2, we are going to convert the given integral in terms of u. But before that, we rewrite it like this. We write the x cube along with dx so that we can easily replace it. Here, this expression gets replaced with u, so it becomes u cubed, and x cubed dx get replaced with du over 20. Now we can move this constant out to simplify. Using the power rule of integral, we get u raised to 3 plus 1 over 4. After simplifying it, we plug in back u to write the answer in original form. This next problem is also similar, where we use the use substitution using the same way, and we get the expression for x cubed dx. For second step, we convert the given integral in terms of u. X cubed dx get replaced with du over 20 on the top and u cube in the bottom. This was a rational function, so this was a little bit different, but the process was same. This constant 20 can be moved out. It becomes 1 over 20 integral of du over u cube. U cubed should be moved up to apply the power rule of integral. After solving the integral, we clean it up a little bit. The negative exponent is written as a positive exponent by moving it to the bottom, and at last we plug in back. Finally, we get this as the answer. For this next problem, this is also a power function, but we can't apply the use up here. Why? Because the derivative of x square plus 1 is 2x and there is no variable x outside. So we can't apply the use substitution here. So what we can do here, we can simplify it by expanding the power 2. For that, either you can use identity, a plus b whole square identity, or you can use FOIL. Write the expanded form and then we can integrate each term separately. The integral of x to the 4 is x to the 5 over 5 plus the integral of x square is x cube over 3. Integral of constant 1 is just x plus c. So when the derivative of inner function is not given along with and power is a small number like 2 or 3, which can be expanded easily, so you should simplify the expression and then take the integral of each term. And next we are going to work on the type when the inner function is a linear function, and linear functions are always cool, they are beautiful. We assume u as 2x plus 3, then we isolate dx. Since there is only dx, here one thing is to be noted, the derivative of linear function is always a constant. So here the constant derivative not necessarily always there. Here the constant derivative 2 was not given along with, but we can easily make the settings. Next we are going to rewrite the given integral in terms of u. 2x plus 3 get replaced with u, so we get u raised to 5. And dx get replaced with du over 2. Constant 2 is taken out as 1/2 and now its integral can be found easily. At last we plug in back u to get the final answer.